This is salt. When the water disappeared from the Mediterranean, this was what was left behind. Millions and millions of tons of it. So much, in fact, that at this salt mine in western Sicily, they're digging out 500,000 tons every year. And they reckon that they can carry on taking that amount for the next 1 million years. Anyone who's ever gulped a mouthful of seawater knows that it's salty. But it's only when you see it dried out like this that you realise just how much salt there is in the sea. For this mine, there's almost more than they know what to do with. So much so that they've even carved their own chapel out of salt, 200 metres underground. Just like every sea, the Mediterranean got most of its salt from rivers. As rivers flow over rocks and stones, they gradually wear them down. This releases salts trapped inside the rocks, which are carried down to the ocean as sediment. Once in the ocean, the salts slowly become more concentrated by millions of years of evaporation. But salt was not the only thing left behind by the vanishing Mediterranean. If you're prepared to really search, you can find leftovers that are far more exciting than plain old table salt. In this cave, there's something so precious that I'm one of the few people who's ever been allowed to see it. It's like being in a modern art installation rather than a geological cave. Look at the light. This is a geode, and these are giant rock crystals, more than a metre long. This is some of the largest crystals I've ever seen. These crystals form when seawater trickling down from above met hot waters coming up from below. And it was in this mineral-rich mixing zone that these fingers of gypsum grew. And they would have stayed there, submerged, if the level of the Mediterranean Sea hadn't dropped, revealing this geological gem. Sadly, I can't stay inside the geode for too long, as the moisture from my body will soon start to dissolve the gypsum, which these magnificent crystals are made from. It's astonishing enough to think that the Mediterranean evaporated once, but in fact, this sea has come and gone many times in the last few million years. And that has had some surprising effects, not just on the geology of this area, but also on the evolution of some of the animals that lived here. During one drop in sea level,
elephants roamed over the old seabed. But when water levels rose once more, they were forced to take refuge on higher ground, on land that was to become the island of Sicily. We know this because hidden in a remote cave, scientists found the fossilized remains of some of those elephants. But that was only the beginning of the story.
This was unlike any elephant walking the planet today. This is one of its actual bones. Now, it doesn't seem that strange until you realise that this is a leg bone. Now, compare this with the leg bone of a modern African elephant, and you'll see that something is absolutely clear. This Sicilian elephant must have been tiny. Now, I know what you're thinking. You're thinking this must have been a baby, but it wasn't. Tests have proven that this is the leg bone of a fully grown adult, just a very wee one. In fact, at just 90 centimetres tall, this elephant was the size of a goat.
The lack of space and food meant that over thousands of years, the elephants evolved into a much smaller animal. Salt mines, crystal caves and dwarf elephants are just some of the extraordinary consequences of a sea that lives on the edge of extinction. Someday, the Straits of Gibraltar will close up again, and then the Mediterranean will disappear once more. Yet the oceans are far more than just reservoirs of water that fill and empty as the continents move. They are crucial for the way the planet works and for the existence of life itself. To understand why, you have to see them not as individual seas, but as a whole, one single system. Even though we can't live beneath the waves, these vast bodies of water are vital to our very existence. Much of that is down to a group of ocean inhabitants that are surrounding me. Single-celled organisms so small they're invisible to the naked eye. They're known as phytoplankton. Although phytoplankton are no bigger than a pinhead, they're one of the most important forms of life on Earth. To understand just how important they are, take a look at them from space. Just off the British Isles, large patches of the sea are stained light green by millions upon millions of individual phytoplankton, known as blooms. These blooms appear around the world's oceans. And it's because phytoplankton are so abundant that they can affect the whole planet. Without phytoplankton in the oceans, there wouldn't be any fish or turtles swimming around. Phytoplankton is the first meal in the ocean food chain. But surprisingly, as well as being a primary source of nourishment for creatures in the sea, these tiny organisms help all animals on Earth to breathe. Phytoplankton can do this because they photosynthesize. They turn carbon dioxide and sunlight into energy in order to live. And this releases a very important byproduct. oxygen. This process takes place on a global scale. All these green patches show areas of phytoplankton, and they're all producing oxygen, which fills the seas and the atmosphere. Oxygen is vital to all animals, in the sea, on land, and in the air. Phytoplankton produce something like 50% of all the oxygen on Earth, about as much as the world's forests and jungles combined.